So, everybody, what I'm going to do is basically bring Baz up on stage and let him take over on this. Let's see if there's Baz. I can see him out there. Hello, sir. How are you doing today?
Hey, Paul, can you just quickly confirm that you can hear me fine?
Yes, there's a little delay between what you're saying and what you're talking, but I can hear your mic. So that I think that's going to be just fine. I'm looking forward to
Awesome.
this. So yeah. So with that, I'm going to let you take it away for the next hour, and we'll have also one other thing. Everybody, there's Q&A. If you take a look on our restream over here on the far right hand side, there are messages that you can ask us and play Stump the Automation Engineer. Always a lot of fun game to play. And with that, Baz, take it away.
Thank you so much for that introduction, Paul. And you almost took the 5 minutes that you promised me, so well done on that. And also well done on pronouncing my last name sort of kind of correctly. So yeah, I know it's quite a hard last name to pronounce for people not actually Dutch like I am. So, but well done. Props to you. And thank you for having me. As you said, as Paul said, I'm going over the next hour or so, maybe a little bit less. I don't know. I'm going to talk a little bit about contract testing. We're going to see consumer-driven contract testing. I'll talk a little bit about bi-directional contract testing. So, but contract testing in general, and for me, contract testing. Paul, can you quickly just confirm for everybody that you can also see my screen, the screen that I'm sharing?
Are all individual components and services able to communicate with one another? We can see that you are 5x5.
Awesome. That is exactly what I wanted you to see. Perfect. Thank you very much. This is basically the question that is so important in modern distributed microservices-based software systems. So we have where we used to have these monolithic systems, we now have systems that are composed out of dozens, if not 100 different components, services, developed in different teams, different departments, maybe even totally different organizations. And you can test all of those individual components till you're blue in the face. But that doesn't mean that they'll all work very well when you stick them all together. You try to reproduce or try to support some kind of end user flow. So this is a bit. So the more distributed your system is, the bigger the problem is of answering these questions. All those individual components and services developed in different teams, organizations, are they really able to communicate with one another? So traditionally, and I've definitely been here, the way we try to tackle this, and the way we still try to tackle this, is in a very, very synchronous way, and trying to test everything at once. So the traditional way of doing large-scale integration and end-to-end testing is try to stick everything together, try to collect all those individual pieces, all those individual components, making sure that they're in some kind of testing environment at some point in time, all with the right data, in the right state, available, exerting the right behavior, and then trying to run some kind of coordinated integration end-to-end tests. And now the more distributed your system becomes, the more components you need to deal with, the harder this becomes. Because all of these components will typically have their own development delivery cycle, which means some components might not be ready at that exact moment that you want to do your integration end-to-end testing. It might be quite hard to set up the right state, the right data in it. It might be really hard to trigger some the specific kind of behavior that you want to use for your integration end-to-end testing. I've seen people basically doing this as a full-time job, making sure that test environments are ready to do this large-scale integration and end-to-end testing. But it's hard, and often it doesn't. It's quite painful as well, and doesn't really work. So Isn't there a better way? Well, this is the exact problem, the exact challenge that an approach like contract testing tries to tackle. And contract-based integration end-to-end testing is different from this traditional approach, basically in two ways. First of all, instead of focusing on the integration of everything at once, so sticking this component A, B, C, and D all in the same environment and try to test all of these as a single entity, contract-based testing focuses on the integration of individual consumers and providers, or consumers and producers, or clients and so whatever you want to call it. So instead of checking if A, B, C, and D can all communicate with one another, you check, well, is A able to communicate with B? Is B able to communicate with C? Is B able to communicate with D? So it breaks down that puzzle of large-scale integration testing into smaller, more manageable pieces. And the second way in which contract testing tries to address the challenges of the traditional approach of integration end-to-end testing is that it's an asynchronous process. So traditional integration end-to-end testing is synchronous, meaning all of those different components have to be in some kind of test environment at some specific point in time. And again, that's hard. And the more distributed your system and your development is, the harder that becomes, because people need to talk to another and say, well, are you ready? Am I ready? Can we stick those in? And well, it's painful. It's just painful. With contract-based integration end-to-end testing, that's an asynchronous process. So, which means that first of all, think back. So we have an integration, and an integration is a combination of a consumer and a provider, and both have to do that due diligence. They're part of the contract testing process, but those two parts, and so they don't necessarily have to do that at the same point in time. The consumer can do their part of the contract testing process as part of their own development and delivery lifecycle, and so can the provider. But that doesn't have to be the exact same point in time, which means it's an asynchronous process, which makes it much, much, much easier to manage, because you don't have to wait. You don't have to necessarily wait on other components to become available again. You can just do your part of the contract testing process as part of your development, your build, and your delivery lifecycle. The way it works typically, and I'm now going to dive deeper into what's arguably the most popular approach to contract testing right now, which is consumer-driven contract testing. So there are currently basically three different ways of doing contract testing. It's consumer-driven contract testing, which I'll show you, which we'll see in a minute. It's provider-driven contract testing, and it's bi-directional contract testing. And I'm also going to talk a little bit about bi-directional contract testing and its benefits later on in this talk. I'm not really going to address provider-driven contract testing, because a provider-driven contract testing is basically a provider saying, well, this is my contract, this is the way I work, this is the specification of my behavior, and all the parties that are consuming this API, well, they just have to deal with it. So it's much more like, this is what I do, you live with it. With consumer-driven contract testing, and also with to slightly lesser extent with bi-directional contract testing, there's much more of a dialogue of, well, this is what I do, this is what you do, let's see if we can work together kind of discussion. But let's look at consumer-driven contract testing first. So the typical way this works is there's a contract. And that contract is the single source of truth, really. And because it's consumer-driven contract testing, it's the consumer who is responsible for generating the contract. So it's the consumer that lays out the rules of the game, really. And the way this works typically is a consumer writes tests. And as part of those tests, it specifies the expectations. And we'll see all of this in code and how it exactly works. So don't worry. The consumer writes down their expectations about the behavior of a provider, the tooling, and we'll see pact as the tooling in a live demo in a moment, generates a contract that contains all of those expectations that the consumer has. From that contract, the tooling, i.e. pact, generates a mock provider which that behaves exactly according to the expectations, which the consumer can then use to test its own implementation. But more importantly, that contract can then be distributed, passed on to a provider. And the provider then has the task, the responsibility of proving, of showing, demonstrating is the word I was looking for, demonstrating that its behavior matches the expectations of the consumer. And please keep in mind, a contract is an agreement between a single consumer and a single provider, which means that if there's a provider service that's being consumed by 4 different consumers, and all of these parties do consumer-driven contract testing, the provider has to make sure, has to demonstrate it can live up to the expectations of all 4 consumers. It has to show and demonstrate that it meets the expectations in 4 different contracts. And yes, there can be mismatches. There can be conflicts of interest. And the funny thing, that's exactly that's something that you won't find out with a lot of traditional integration testing. It's not something that you can typically figure out just by testing the provider or just by testing the consumer. But it's a type of bug defect that typically only shows when you do this kind of contract testing. So a little bit more about these expectations. So again, we have a consumer, we have a provider. This is the flow. No, the different sheet. I was expecting a different sheet here. Don't worry. These expectations, let's talk about these expectations for a bit. They are typically in the form of a consumer saying, well, if I do this, if I send this kind of request, and the provider is in this kind of state, then I expect the response to look like this. As an example, as you'll see in the code example that I'm going to show you, has a single provider that takes care of address data. This is all within the context of a web shop. And that address data, that address provider service is consumed by 2 different consumers. A customer component, a customer service, which maintains and distributes data about customers. Customers have addresses, typically billing addresses, for example. And if you want to have get all the data related to a customer, you also want its address data. So that customer component, that customer service consumes the address data to retrieve and present the data that's associated with a specific customer, for example. And we have another consumer, which is the order consumer, which manages data around orders in a web shop. And an order has an address as well, be it a delivery address, for example. So both of these, there are 2 consumers and 1 provider, and both consumers rely on the behavior of that provider. The way the typical consumer-driven contract testing workflow with tools like pact works is we have a consumer, we have a provider. there we go. We have a provider and we have a broker. And that broker, that pact broker, acts as a kind of central source of the central registry, central library for all the contracts that live within a specific context. Plus, it stores contract verification results, meaning that it's for the consumer-driven contract testing flow. It's the consumer who uploads their contract, generates and publishes that contract as a first step in the flow. The second step in, again, a traditional consumer-driven contract testing flow is the provider downloading the contract and verifying the compliance, meaning demonstrating whether its current implementation is able to meet all of the expectations in that contract or in the contracts. As a third step, it publishes the verification results. And the final step is that both the consumer and the provider can then query the broker, which again has all the contracts and all the contract verification results, to see, well, now A, has everybody uploaded their contracts and the verification results? And B, are there any known integration issues? Or basically, to rephrase it, is it safe to deploy? Can I deploy? That's literally the name of the tool in the pact ecosystem that you can use to do this, to query the pact broker to see, well, with the current state of our contract testing, are there any potential integration issues that might break something in production? Let's have a look at how that works in practice. So here's is this font size big enough, Paul, or do you want me to zoom in a little to increase the font size a little in my editor? I'm going to interpret your quiet as this is okay. Let's start at the consumer side. For now, in the current state of the code, it doesn't really matter if I'm starting with the customer or consumer or with the consumer, because the current state of the code, they both have a set of expectations, and those set of expectations are exactly the same. So let's have a look at the customer-consumer test code. In this test class, I'm basically two things here. As I said, I'm specifying the expectations that the customer has about the behavior of the provider in certain situations. So again, keep in mind this customer, both this customer consumer and the order consumer communicate and rely on the address provider. In this example, I've specified expectations for two different paths.
Hey, Bas, I'm sorry to interrupt. Yes, I was backstage for a second here. I was going to say, yeah, maybe if you can zoom it in a little bit better, a little bit more, it'll probably be better for us.
No worries at all. Let me quickly increase the font size a little. There we go. So I'm doing two things here. A, specifying the expectations that the consumers have about it, and then running tests that actually generate segments of the contract, and write the expectations to the contract, and also test the implementation of the consumer itself. So assuming that the provider behaves as expected, am I able to successfully process the responses? I've specified two paths here. So for HTTP gets, so retrieving address data, and for HTTP deletes, so deleting address data. I've not really bothered with coming up with examples, for example, for HTTP posts, for creating new data, but the principle is really the same. So for the get, so for retrieving address data, I have three different situations. I have the situations where I specify, and so I retrieve address data using an ID, and that ID is formatted as a UUID. So an address is uniquely identified by its UUID. And then three things can happen. The address ID is valid, and there's address data associated with that address ID in the provider, which should yield an HTTP 200 as the response code, plus data in a shape that the customer can understand and process. The second situation is, well, the address ID is valid, but there's no data, which means I expect to receive an HTTP 404, not found. And the third one is, what if that address ID is incorrectly formatted? So the customer can't guarantee that the address ID that's going to be sent is actually a valid UUID. So it wants to know that in case the provider receives an incorrectly formatted address ID, it should respond with an HTTP 400 bad request, basically. So for the 404 and the 400 situations, that's the HTTP status code is really the only expectation that's written out. So for a GET, if the request looks like this, I expect the response to have a status 404 and a 400 for these two situations. The situation where I actually expect data, so the HTTP 200 situation, the OK situation, I have some additional expectations because I have some expectations as a consumer about the shape of the response, meaning what does the response data look like? I don't have expectations about the actual values because that's testing the implementation of the provider, which I expect the provider development team should do. The developers or testers, automation engineers on their end don't really care who does it as long as they do it. But what I do expect is retrieving data in a shape, in a form that I can process. And that's where these expectations come in. So basically what this says, this is pact in Java, which allows me to specify using some nifty utility methods, what does the shape of the response data look like? So basically what it says here, I expect a field address type that should be a string. I expect a field street in there that should also be a string. I expect a field number that should be an integer, and so on and so on. This is a little bit of a special one. This is a utility method that generates a slightly stricter expectation. Basically, this says, well, I expect a field ID in there, and that should be not just any string, it should be a UUID. And basically that comes down to, well, it should be a string, but not just any string, but a string that matches a specific regular expression, namely that of a UUID. That regular expression that you can use to determine whether or not a string is a valid UUID. That is all those expectations during test execution are written to the contract. So let's just do that, run the test on the consumer side first. It is a little slow at the moment, but I can guarantee you it is running the tests at the moment. Or rather, it's compiling at the moment and it should start running the tests any moment. There we go. And when I run the tests, again, two things happen. A, I'm generating a contract, which can then be uploaded to the broker, so the provider can download it and use it to verify its compliance against the expectations in those contracts. And B, from that same contract, a mock provider is generated, which can then be used to test the implementation of the consumer itself. And both those things happen when I run these tests. So it tests the implementation of the customer consumer, and it also generates the contract. which, no, I don't want to do that, which ends up here. So this is the contract, and it's the contract between the customer consumer and the address provider, and it contains the expectations about what the response of the provider should look like in certain situations. So for example, in the situations where I do an HTTP GET and the address ID matches an existing address, this is an example response. And if I look at the matching rules, I see that, well, for example, for the address type, the actual value that is returned by the provider should match the type of this example. And the same for the city, the country, the number, the state, the street, the zip code. And again, that ID, which had this UUID, which we generated using this UUID method, says, well, it doesn't just have to match on the type. The actual value has to match this regular expression. And so we know that the value for the ID shouldn't be just any string value. It should be a valid UUID. I'm going to do the same for the order consumer, because that needs a contract too, that I want that contract as well. And again, in the current situation, the expectations that the order, so the other consumer that relies on the same address provider are exactly the same. I'm not going to show that to you yet, just have to believe me for now. The expectations that the order consumer has are exactly the same. So I shouldn't, as of now, I shouldn't expect any problems here. So this takes a while. Let me take the time to quickly introduce to you the pact broker. Pact Flow is a pact broker. It's a cloud-based pact broker. You can also there's also an open source version. So this is again a disclaimer. This is a paid product with a free plan. There's also an open source pact broker which you can host anywhere. It's a Docker image that the people behind Pact have made available. I'm using this one just for simplicity, really. But everything I'm showing you right now can be done with the open source Docker-based pact broker as well. I'm quickly going to go back to the customer consumer, because what I'm going to say now, again, we've run the test, generated the contracts. I'm now going to say, well, please publish that contract to the broker. And I'm going to do the same for the order consumer. So before I refresh, there is nothing here. It's a completely empty environment. Yep, that's done. And if I refresh PackFlow now, you see that it now has two integrations, so two known contracts, one between the order consumer and the address provider, and the other between the customer consumer and the address provider. We can even zoom in and see, well, what interactions, so what specific situations are specified in that contract. So again, we have 3 situations for the customer get and 2 for the delete. But more importantly, as of now, those contracts are unverified, meaning the consumers have uploaded the contracts, have uploaded their specifications, but at the moment, it's still unknown whether the provider, in this case, the address provider, can meet all the expectations that are written down in this contract. So let's go over to the address provider side. Here they are conveniently in the same code base, which obviously will never happen in real life, but it doesn't really matter because we have the broker to manage and distribute our contracts. test here. I decide that literally pools all contracts occur, and then for all the states, for all the situations, generates a mock consumer from the intent in the contracts, invokes the actual provider, and then checks if the responses returned by the actual provider match the expectations in the contract. So if I run pact.verifier.log. So by default, if I run the tests, it doesn't automatically upload the results, but I like to live a little bit dangerously, so I'm going to upload them right away. This runs my tests on the provider side, which again pulls the contracts from the broker, runs them against the actual implementation of the provider, checks whether the responses returned by the provider meet the expectations in the contracts, and then uploads those verification results back to the broker. So we are going to have to wait a little bit for the address provider to do their magic. Build success. Hooray. Let's have a look at the feedback in Flow now. And indeed, for both integrations, it says, well, we have a success. So, which means that there's a contract which was published 4 minutes ago and just verified, and all of the interactions have been checked success. So the current implementation of the provider is able to meet all of the expectations for both the consumers, meaning everything is fine in integration testing land, and it's safe for the customer consumer, the order consumer, and the address provider to deploy the latest version into production. If we change that a little, so for example, let's just do a very quick change. In case of an HTTP delete for where the address ID is correctly formatted, I am no longer going to expect a 204, which is sort of kind of a de facto response for a successful delete. It's no content, basically. Let's say, well, no, the customer consumer in this situation now expects an HTTP status code of 200. What I then need to do is run the tests again, because I want to know that this doesn't break my consumer implementation, and I want this new expectation. So the fact that the customer consumer, in the case of a successful HTTP delete, expects a response status code of HTTP 200 instead of 204. I want that written to the contract, because that's new info. That's a new expectation that the customer consumer has about the behavior of the address provider. And the only way the address provider can be informed, can know about those updated specifications is, well, it needs a new contract. It needs an updated contract. So that's what it's going to do now. It's running the tests again. And this typically is a little bit, I think my machine is a little bit slow today, but that gives me some time to fill the time and to explain to you what's actually happening. And if I now publish that new contract, there we go. And refresh this, the pact broker will see, well, there's a new version of the contract, which is as of yet unverified. So here, nothing has changed. I've really only changed the expectations for the customer consumer, which yielded a new contract, which is as of now unverified. And if we go back to the address provider, Let's see, is this in my history still? Of course it is. To run the tests on the address provider side again. So it downloads the updated contract. It sees, well, there's new contract. I need to, there's new set of expectations that I need to meet. So it's pulling in that new contract. It's going to try and test whether can I still meet all of the expectations in all of the contracts. And I assume you sort of kind of know where this is going, because no, the current implementation of the address provider is not able to meet these expectations. It has failed now. So this one is still a success. So the current implementation of the address provider is able to meet all of the expectations that the order consumer has. However, there's an expectation that the customer consumer has expressed in their latest version of the contract that the address provider is no longer able to meet. And that's this one. So in the request to delete an address, well, I said, it has status code, but so the contract specified an expectation of, well, in this situation, I expect a status code 200, but it was a 204. So what the address provider actually returns is an HTTP status code 204. I could change the implementation of the address provider to return an HTTP 200 instead of a 204 and run the test again, but then it would break the expectations of the order consumer, because that one still expects an HTTP 204. And this is what I mean when I talked earlier about conflicts of interest. So the customer consumer has its set of expectations. The order consumer has its set of expectations. The address provider has its assumptions about how it should work. But whether or not all of these expectations match, you can really only find out when you do integration testing. And again, the order consumer, the customer consumer, the address provider, these three components, these three services might be developed in different teams, in different departments, in different organizations even. And that means that you really need some form, some structured way of making sure that you, preferably in an automatic way, in an automated manner, check whether the expectations that parties have about the behavior of other components, if they're actually true, if they're actually if they are realistic, if there are no conflicts of interest. And that's exactly what contract testing is trying to do. And that's exactly the way in which contract testing tries to address that question that I showed you on the first slide. Are all of these components at all times in a distributed system able to communicate with one another? That's the whole premise of contract testing, really. Now, I showed you an example in Java. The nice thing about pact is that it's available for many different languages, including Python, C#, JavaScript, PHP, Go, and a couple of others as well, Ruby, which also means it's quite useful. So if your consumer is written in Java, but your provider is written in C# or in Go, for example, that's fine, because these contracts are basically JSON files. So they can be exchanged between a consumer in one language and a provider in another language, which is quite nice and makes pact a really versatile tool, because with these distributed microservices-based systems, you don't always know what the technology stack is that the other party is using, and you don't want to enforce that, maybe. Or maybe you would, but you're not always in the position to enforce that. And pact does this really in a programming language and technology stack independent way, which I think is quite nice. So is this, well, the solution to everything? Well, no. But at first, I wrote a blog post series about contract testing, about the benefits, about how it works. If you have a look at this link, it's a 6-part blog post series. This is the first one, which links to all the other articles. But so what we've looked at, what I've shown you just now, is the not traditional way, but the consumer-driven way of doing contract testing. But it has some implementation challenges. First of all, it requires teams to write tests. As you see, well, it's when tests are run, only then are the contracts generated. There's still some coupling between the consumer and the provider by means of those states that you've seen, which means that consumer-driven contract testing doesn't always scale well to really large numbers of consumers. Getting provider teams on board can be difficult because it requires a lot of work for them to say, well, what are all the states and the different contracts, and that requires a lot of work, and I don't want to. So it can be difficult to getting these provider teams on board and really showing them the value of consumer-driven contract testing. And it can also be quite hard to getting testers on board because you're really working at the unit test level. It's closely tied to the implementation of the services, which means it can be a little bit harder to get testers on board. And so contract testing is nothing really new, although it has seen quite the surge in interest and popularity over the last year and a half, 2 years maybe. But there's quite a few challenges when you try to implement consumer-driven contract testing. And this is where bi-directional contract testing comes in. So that's a different approach to contract testing. And a big disclaimer here right away is that bi-directional contract testing is supported only by pact flow. Because what I'm going to demonstrate to you now is not something you can do with the open source Docker-based pact broker. This is something that's only supported in pact flow. So this is the flow that we've just seen. So it's the consumer that's in charge, generates the contract, gives that to the provider shows whether or not it's able to meet the expectations in the contract, and then both can check, well, can I deploy? The bidirectional approach to contract testing is a little bit different. It's no longer either the consumer or the provider that dictates what's going to happen. No, with bidirectional contract testing, they can each of those parties, those two parties, can each give their own version of a contract. And then it's the pact broker that compares those contracts and checks whether or not there are any integration issues, basically. So it's no longer the consumer giving a contract to the provider. It's also not the provider giving a contract to the consumer, because that would be provider-driven contract testing. No, it's both parties giving a contract to the broker, and then it's the broker that checks for compatibility. And then again, if once the pact broker has done that, and again, this is supported only by pact flow, not by the OSS pact broker, then both parties can check, well, is it safe to deploy? And what's super nice, I think, about bidirectional contract testing is that you no longer even need pact to do it. So you still need pact flow, but you don't need necessarily, you can do it using pact, but you don't need to do it using pact. You can leverage a lot of existing technologies and the range, the collection of supported technologies grows by the week almost. But you can derive contracts from existing technology and tests. So I'm going to show you a different example where I no longer call 6. And Paul, I'm going to just trust you on telling me when I'm running out of time, but if not, I'm just going to continue or waffle on. So I switched to a slightly different branch here, which introduces another integration. That is an integration between the order consumer and a payment provider, which is a party we haven't seen until now. But orders, they need to be paid for, so there's an integration between the order consumer, which again takes care of all the data around orders, and the payment provider. As basically, it can, in this case, it queries the payment provider to see, well, are there any known payment? Is this order already paid for? What's the nice thing about bidirectional contracts? And let me also start Postman while we're waiting. What's nice about bidirectional contract testing, again, is that you don't necessarily need to use pact. If you're using popular, mostly open source tooling to write API tests or API mocks, there are good chances that pact already supports it. So in this case, the order consumer already has some tests that test whether its current implementation can work with an implementation of the payment service provider. And because it doesn't want to rely on the actual payment service provider, it uses WireMock to do this. So for those of you who don't know, WireMock is an HTTP API mocking library in Java, open source, quite popular. And that's what this team has been using. And the nice thing now is that you can use these existing integration tests or integration kind of tests that use a mocked version of the payment service provider, again, mocked in WireMock, to generate a contract. And the way that works is when I start up my WireMock server here, I'm adding the WireMock pact generator. So that's a library. It's basically a listener that you add to WireMock. Again, WireMock will spin up a local HTTP server, which listens to incoming requests. And then if it has a known predefined response for it, it will return that response. If not, it will return a 404. And this pact generator is basically a listener that checks, well, during the running of these tests, which again are some tests using that calls the payment service client, which invokes this base URL to retrieve payment for some kind of order. It's going to use the actual traffic, so the actual request that arrives at the WireMock server and the response that the WireMock server returns, so the mock server returns, to generate the contract, which means it doesn't rely on specifications expressed using the pact library. It's going to use the actual traffic that's being generated when you run the tests to generate the contract. So if I go back to the order consumer now and I run my tests again in this branch, it will run all the tests that it ran before, but it will also now run these tests against this mocked version of the payment service provider. It then generates a contract as well. So it takes a while. It generates a contract between the order consumer and the payment provider, which expectations, or rather, because in the mock, in a typical mock, you define how you expect the actual service to behave, but don't want to rely on the actual service. And it uses those expectations that are codified into this mock to generate that contract. So it takes a little while to run the tests again. Almost there. There we go. And now I have... Oh, it hasn't refreshed properly. Come on, reload from disk. There we go. There's also a contract between the consumer and the consumer and the payment provider. If I now publish that to pact broker again, it publishes this one. That was already okay. This one is now created. There's a new integration that as of yet unverified, because it's the order consumer who uploaded their contract to the payment provider. Now, this payment provider is a public API, and public APIs and consumer-driven contract testing do not go nicely together. So if you have public APIs, trying to make those provider sites do consumer-driven contract testing is going to be virtually impossible, because, well, it's a public API. It's basically the provider saying, well, this is what I do. But what's a nice thing about this public API, they typically have some kind of contract of their own. And one of the shapes that contract can take can be as simple as the open API specification of that service. In this case, my payment provider service. And that probably has, and it's quite likely that that's public, so that you can use that to do your contract testing. Because this too is a form of this open API. It's a form of a contract because it describes the behavior of the payment provider. So it describes, well, these are the paths that I support, the HTTP methods that I support, and these are the HTTP status codes and the shape of the responses that you can expect. So let's quickly look at this flow again. So I've done the left-hand side now. I've used consumer. Again, it uses, instead of using pact to generate the contracts, it used that wire-mocked pact generator, that listener, to listen to what's happening during my tests and generate the contract from that and upload that to the pact broker. But the provider can now also, let me just quickly, I'm going to need to encode that because that's the format that oh no, I don't want to do that. There we go. As of now, there's a bit of an arcane API call that I need to make to upload that actual contract. But what I'm doing is con HTTP put to my broker. I said, well, there's this payment provider version 100. This is the contract. It's an open API specification kind of contract, which is a YAML file. And you can upload some additional verification results. As a provider, that's a courtesy thing to do. So, well, this is, for example, this is what I did to prove that my implementation is correct. But the most important thing is, well, it uploads the actual contract. So if I send that, it tells me created, and now the provider has uploaded their version of their version of the contract as well. And what Pactflow will now do is compare the consumer contract, which again generated from these YMOC-based tests, and the provider contract, again this open API specification, and see if there are any potential integration issues. And in this case, there's a success. We can view the contracts, the consumer contract, which contained these paths, and the provider contract, which was this open API specification. And it's the pact broker that did the comparison. And again, this is supported only by pact flow, not by the OSS pact broker. So in turn, I see it's almost 6 on my end. So I'm going to wrap up and free the stage for Jonathan. But what's nice about bidirectional contract testing, when you compare it to consumer-driven contract testing, is that it's much easier to get started with, because there's a lot of existing tests and infrastructure and existing specifications and contracts that you can leverage to get started with contract testing. Again, the goal is the same. It's finding out at any given point in time, can consumers and providers successfully talk to one another. That's still the whole point of contract testing, no matter if it's consumer-driven, provider-driven, or bidirectional. It's just with bidirectional, it's easier to get started if you already have some existing tests or infrastructure in place. With consumer-driven contract testing, you need pact, you need to write those tests, you need to write the specifications, which works very well if you're starting a greenfield project, for example, or everybody really wants to do it, which is unfortunately not always the case. But bidirectional is just easier to get started with, because it's much easier for both parties. So, well, I've already got these tests, this technology, and if pact supports it, and again, the list of supported tools and technologies it includes, so it can do Postman collections, for example. It can use Postman collections, Cypress tests. I've showed you WireMock. It can do wiremock.net as well. It can use rest assured tests. So for the provider side, where you say, well, I'm testing my provider implementation with rest assured test, it can use, well, what's happening in those tests as a provider side contract. So it typically takes a lot less effort to start with bidirectional contract testing. I've got some links basically, and that I'm done. Pact flow. If you go to the pact flow site, you'll be able to find a lot of information in the background about why bidirectional contract testing came to be in the first place. My blog post series also has one post on bidirectional contract testing. And the code's all on GitHub. So if you go to my GitHub page to this repository, you'll find all of the code that I've shown you in this talk. And that is it from me, Paul.
That is terrific, Bas. Thank you so much. I am looking over here to see if there's any questions, and we didn't get any questions up on this. So this is pretty cool. I learned a lot about this. I really need to get more into API testing, and this pact flow. Where is it? Like pactflow.com? We can take a look at that. Is that where we can?
It's pactflow.io.
Pactflow.io. Excellent.
If you go to pactflow.io, you'll find everything, and it's not just it has a whole lot of documentation and other information about it as well. There you go.
All right. Cool. Any last any ways we can contact you? Any ways that you want, anything you want to share with everybody on where we can see more about that?
Well, basically, if this shameless self-promotion, this is my site, and you'll find contact form and everything on there on testautomation.com. That's the easiest way to get in touch. Email or maybe LinkedIn. There's a contact form. That's it, really.
Terrific. I did notice something else when you were using IntelliJ from JetBrains. I love their IDE. Anything in in IntelliJ that you want to share? Like, I mean, we have a choice. You've got VS Code, you got Eclipse. Nobody uses Eclipse anymore. But
You'd be surprised. You'd be surprised how many people still use Eclipse.
I'm a little jaded. I worked on Eclipse for 2 years, and I went, you know what? I actually love JetBrains. I love their tools. I'm actually working in WebStorm right now in JavaScript. So
What I love about it, it's basically everything is 90% IntelliJ anyway. So like yourself, probably, I work with quite a few different programming languages, and I love the fact that with all of these programs, at least the IDE looks the same.
Yes.
So whether it's as you said, WebStorm or PyCharm for Python or IntelliJ, yep. And for some reason, I then still use Visual Studio if I do C# work and not Rider. But okay. Don't ask me why.
I won't. Hey, Bas, thank you so much for joining us. I really appreciate it. I'm going to get Jonathan on here in just a minute. And cheers, and thank you so much.
You are more than welcome. Thank you for having me.